We have discussed in the previous lecture that there are 7 types of logic gates. The first type of logic gate is the AND gate, which we have already discussed in the previous lecture. Today we will discuss the second type of the logic gate, which is the OR gate. The OR gate is a logic gate which has 2 or more than 2 inputs and 1 output. The OR gate is used to perform logical OR operation. The output of an OR gate is high if either of the inputs are high, and its output is low when all the inputs are low. The logic symbol and the truth table of OR gate has been shown in the figure. So from these figure we find that this is the logic symbol of an OR gate. Logic symbol of an OR gate. That is, an OR gate is represented by this symbol. So if we want to draw the logic symbol of 2 input OR gate, then we will make the symbol of OR gate and we will show 2 inputs to this OR gate, and since there is only one output, so the output has been represented by Y. So this gives the logic symbol or the logic diagram of the 2 input OR gate. Similarly, if we want to draw the logic symbol of 3 input OR gate, we will draw the symbol of OR gate and we will show 3 inputs and 1 output. Similarly, if we want to draw the logic symbol of n input OR gate, then we will show n number of inputs to this OR gate, and since there is only one output, so we have shown a single output which has been represented by Y. So this gives the logic symbol of n input OR gate. Now for writing the logic formula of the OR gate, we know that the OR gate performs the OR operation, and actually OR operation means addition operation. So the logic formula of 2 input OR gate will be A plus B. That is, an OR gate adds the inputs. So for 2 input OR gate, the logic formula will be A plus B. That is, output will be equal to addition of the inputs. Similarly, the logic formula of 3 input OR gate will be Y is equal to A plus B plus C, because in 3 input OR gate there are 3 inputs A, B and C. So we have added all the inputs to get the output. Similarly, for n input OR gate, the logic formula will be output is equal to addition of all the inputs, that is A plus B plus up to n. So in this way we can write the logic formula of the OR gate. So we see here that if A and B are the 2 inputs of an OR gate, then the output expression in case of OR gate is written as Y is equal to A or B. That is, an OR gate performs OR operation between the inputs. So the A and B are the inputs. So the output Y will be equal to the OR operation of A and B. An OR operation is nothing but it is plus symbol or addition operation. So this can be written as Y is equal to A plus B. Now let us draw the truth table of 2 input OR gate and 3 input OR gate. As we have seen earlier, that truth table is a table which shows the relationship between the input and the output variables. So we have drawn a table showing the inputs and the output variables. Since this is a 2 input OR gate, so there will be 2 inputs which has been denoted by A and B, and since there is a single output, so the output is Y, and and the output will be equal to A plus B. Again, we know that the inputs can have only two possible values, 0 and 1. So we have substituted all the possible values of the inputs. In the first case, the value of both the inputs has been taken as 0. In the second case, the first input is 0 and the second input is 1. In the third case, the first input is high and the second input is low. And in the last, that is in the fourth case, the value of both the input is 1. When we find the output in each case, then we get 0 plus 0 is 0, 0 plus 1 gives 1, 1 plus 0 gives 1, and 1 plus 1 is 1. We can understand this as high plus high will give high, true plus true gives true, positive plus positive gives positive. So we can write 1 plus 1 is equal to 1. That is why we say that these gates work on logic. So in this way we find that the value of the output is 1 if either of the input is 1, and the output is 0 only when all the inputs are 0. Similarly, if we write the truth table of 3-input OR gate, again we find that in this case the output is 0 only when all the inputs are 0. In all the other cases, the value of the output is 1. So in case of OR gate, the output will be high if any one of the input is high. Now let us consider the third type of the logic gate, which is the NOT gate. NOT gate is a logic gate having one input and one output. Only NOT gate is a logic gate which has one input and one output. And the output of the NOT gate is always the complement of the input. That is, if the input is high, then the value of the output will be low, and if the value of the input is low, then the output will be high. The logic symbol and the truth table of the NOT gate has been shown in this figure. The NOT gate is represented by this triangle and a bubble. Since the NOT gate has only one input, so the input has been denoted by A, and it has one output, and so in this figure we find that the output has been denoted by Y. So this is the logic symbol of NOT gate. The logic formula of the NOT gate will be, we know that NOT gate performs NOT operation, so Y will be NOT A, and NOT A can be written as A dash or A bar or A complement. All these are same thing. This is the logic formula of the NOT gate. If we draw the truth table of the NOT gate, then we find that when the value of A is 0, the value of the output is 1. Whereas if the value of input A is 1, then the value of the output is 0. So we find that the NOT gate is used to produce the complement of a variable in Boolean algebra. So it is also called as a complementing or inverting circuit. In the next lecture, we will discuss the NAND gate and the NOR gate.